The land before our time, a place with many unknowns, but what do we know about Earth's past? Throughout history, there have been various geological events across Earth that have resulted in mass extinctions. A mass extinction can be defined as a rapid loss of biodiversity at an uneven rate. There have been 5 major extinction events so far. However, our focus will be on the Permian-Jurassic event and the Triassic to Jurassic period. In 1912, a man by the name Alfred Wegener proposed a theory of continental drift, the mechanism behind the breakup or rifting of Pangaea. It was later explained by the movement of plate tectonics, where the Earth's lithosphere consists of large rigid plates which are in constant movement, moving together at subduction zones, splitting apart at oceanic ridges, and moving along each other at fault lines. From the Permian era to the beginning of the Triassic period, the Earth's major land masses were all formed together as a supercontinent Pangaea. Over time, plate tectonic activity started to increase rapidly and continental drift began, splitting Pangaea into 2 main land masses, Laurasia and Gondwanaland. At the end of the Jurassic period, Pangaea was divided, and by this time 2 major global extinction events had occurred, wiping out large populations for both marine and terrestrial species and shaping the course of history as we know it today. But what was the cause of these mass extinction events? Let's start by taking a look at the event that took place 252 million years ago. The Permian-Jurassic event, known as the Great Dying Extinction Event, is ranked first in severity of the 5 major extinction events in geological history. It was a time where conditions were extreme. Approximately 90% of marine species and 70% of terrestrial species became extinct at the end of the Permian era. There are multiple theories as to why such a mass extinction occurred. One of the major theories points towards volcanic eruptions that created flood basalts. Occurring in what is now Siberia, these historic volcanic activities led to an increase in carbon dioxide and sulfur dioxide being released into the Earth's atmosphere. This caused the ambient climate to heat up and create a greenhouse effect. Earth's temperature rose approximately 5 degrees higher, and oxygen isotopes show evidence that the ocean during the Permian era had a mass increase in temperature also. This followed into the early Triassic. It can be contributed due to the dramatic rise in ocean temperatures, which caused the sea ice to melt and release a mass amount of methane into the ocean, as well as dissolve CO2 and a depletion of oxygen in the water. It created a toxic environment for marine life to live, hence the massive decline in marine species at the end of the Permian era. Now, let's take a look at the Triassic-Jurassic extinction event. The Triassic period was the first period of the Mesozoic era, beginning roughly 201 million years ago. It was then succeeded by the Jurassic period. There are 4 major theories behind the cause of this event: volcanic eruptions, climate change due to increased carbon dioxide, sea level fluctuations, and possible asteroids. It is believed that the global biological extinction crisis was caused due to the outgassing and emplacement of enormous volumes of magma over a relatively short duration of time. This extinction event has been thought to be associated with the eruptions located within the Central Atlantic Magmatic Province, known as CAMP, which is the most extensive large igneous province on the planet with an estimated volume of 2 to 3 million cubic kilometers of magma. The source of the Central Atlantic Magmatic Province is believed to be from the processes of plate tectonics and mantle plumes, including large volcanic provinces created through flood basalts. A volcano is a crack or hole in the Earth's mantle that enables hot lava and gases to escape from a magma chamber from below the Earth's surface. It can erupt, forcing gases and hot lava into the air, from a result of many reasons such as plate tectonics, which can push the gases and lava into the chamber. They can also result from increases in pressure and decreases of temperature. Massive volcanic eruptions at the end of the Triassic period cause hot lava and gases such as carbon dioxide to be expelled into the Earth's atmosphere. This would have resulted in the ultimate warming of the Earth, which would have resulted in the killing of many marine and terrestrial species. It was at the end of the Triassic extinction event that dinosaurs then became the most dominant land species. Much like the 6th mass extinction event occurring today, it is believed that the previous extinction events were caused due to rapid changes of the environment. Back then, they were caused by high levels of carbon dioxide in the atmosphere, which were expelled from erupting volcanoes and large igneous provinces. Today, however, they are caused by a highly increasing industrial world. We must reduce our release of methane and carbon dioxide into the atmosphere if we are to mitigate the next mass extinction.